do one so we could remember how to do these because it is part of what you have to do. So you've got x squared y minus x over y equals negative 2. So remember, implicit differentiation is when you got the x and the y's, and if you take the derivative of anything with a y, what do you have to put with it? dy dx. So we're going to have x squared times the derivative of y, which is dy dx, plus y times the derivative of x squared, which is 2x. You got to use the product rule on that first part right there. What have we got to use on the second part? Quotient rule. So we got minus y times 1 minus x times dy dx all over y squared. And that is going to equal 0. You've got trying to decide what I actually think we're going to have to do common denominators at some point. So there's several ways you could deal with this from here. what I'm afraid of, what we cannot do is we cannot multiply both sides by y squared and get that, have it multiply by that 0. It's going to go away. It's not going to give us the right answer. So I think our best bet, let's add this over here. Honestly, I'm going to take everything. Like, I know this dy dx right here really needs to be over on the left side, but I'm going to go ahead and move it over here so I can just multiply everything by y squared, and I'll move it back. There's so many different ways you could go from here. So actually, let's just do this. Let's do x squared dy dx plus 2xy. And let's move, since that's a minus, let's move all that stuff over here. Y minus x dy dx over y squared. And then we can multiply both sides by y squared to get that y squared out of the denominator, because it's a problem when it's in the denominator. And this would have to be distributed here. So we'll have x squared y squared dy dx plus 2xy to the third equals y minus x dy dx. Well, okay here. Now you're down to like your basic sort of solving for a dy dx. We'll move everything with dy dx to the left. I'm going to go ahead and factor it out. So you'll have dy dx. You'll have x squared y squared. Whenever you move this over here, it is going to become positive, so you'll have a plus x right there. And then it will equal y minus 2xy cubed. And then you just have to divide. So dy dx is y minus 2xy cubed over x squared y squared plus x. It may or may not match that perfectly. Which answer choice is it going to be? It's going to be B right there. Ours, we can switch that to make it x plus x squared y squared. There. Okay, so that is review. That is something we have already done. It's a little bit of a difficult problem on that because you got the product and the quotient rule that you have to do there. But we're going to have to do that for some of these problems that we're going to look at. So I wanted to throw that in there. Okay, so let's look at the type of problem that fit in this section. C is the curve defined by xy equals -4. Which of the following statements is true of curve C at the point -2, 2? Okay? So if you look at your answer choices, they can kind of lead you to what you're supposed to be doing. It talks about relative minimum or relative maximum, increasing concave up, increasing concave down. And it gives you information about the first derivative and the second derivative. So essentially what you're going to have to do is find the first derivative, plug in this point, and then find the second derivative and plug in this point. And we're going to have information about those derivatives that we can match to one of these answer choices. Okay? So they use a y prime and a y double prime. I do not usually use that notation with this type of problem. But y prime would be dy dx, and this would be d squared y over dx squared. So that's the same notation. Like that's it means the same there. So if we take the derivative of xy equals -4, this is a product rule right here. So we've got x times the derivative of y, which is dy dx, plus y times the derivative of x, which is just 1, and that will equal 0. So we will move the y over to the other side. So we'll have x dy dx equals -y, and we will divide by x. So dy dx is going to equal -y over x. And so I'm going to plug -2, 2 into this derivative to see what I get. So if I do dy dx, -2, 2, that is going to be -2 over -2, which is going to give me a +1. So which ones of these can I eliminate at this point? A and B are not correct because my first derivative does not equal 0. So I might, no, I can't answer this question yet. So you want to check, I know my first derivative is positive. Both of these answer choices have the derivative being positive. What does that tell us if our first derivative is positive? The curve is increasing. Both of these say increasing, so this doesn't. If one of those said decreasing, we could throw that out. We would be done. We wouldn't even have to find the second derivative. But we have to find the second derivative here. So if I take dy dx and it equals -y over x, I need to take the second derivative of this. To do that, I need to use quotient rule. So I will have x times negative dy dx minus -y times 1 all over x squared. Now, for this, you could take dy dx and plug it back in, or we've already found dy dx at this point. So I know dy dx at -2, 2 is 1. So when I have that dy dx right there and I'm plugging in the point -2, 2, I can just plug in 1. That's going to be your quickest way to do this. So if we do, I wouldn't even really simplify much here, such that xy equals -2, 2. I will have -2 times, I've got negative dy dx, that's going to be -1, because at this point, the first derivative is 1. That's going to become a plus y, so +2 over x squared, so -2 squared. So I will get +2 plus 2 over 4, and I get 1 for that as well. So I have a positive second derivative. The conclusion is not really even important because this one says I have a negative second derivative. But the positive second derivative tells us that we are concave up, so C is going to be your answer for that. When you're doing implicit equations, they have to give you a point to test pretty much, because unless you only have one variable in your derivative, you can't really test it very well otherwise. So you won't find yourself like doing charts a lot for this. You'll find yourself plugging numbers in. Okay. Questions on 2? Okay. All right. 3, ask us to consider this curve. It gives us the first and second derivative. We do not have to find them. They're given to us. Which of the following statements is true about the curve in quadrant 4? So let's look at our answer choices first. Does anybody see some answer choices we can throw out before we even look at this problem? Okay, A and B can go. Why? dy dx does not tell us anything about concavity, right? First derivative does not tell us about concavity. So A and B are out. So that means the only ones we're really looking at are C and D, and those both deal with the second derivative. So do I even really have to use the first derivative? No, they've just given it to us like as a distractor here to make you think first derivative maybe is concavity. So let's think about, we're only looking at the fourth quadrant. What do we know about the signs in the fourth quadrant? They're not both of them negative. Positive, negative. Okay, so d squared y over dx squared, second derivative, is negative 81 over 16 times y to the third. Now, I don't know what the y is, but if I'm in the fourth quadrant, what do I know about the y? It is negative. So if I think about this, I'm going to have negative 81 minus 16. You can use a number here if you want, or you could use or whatever. I'm just going to put a negative 1 there. It's a possibility, right? That could be something that's in that case. What happens when I do negative 1 to the third power? Still negative, right? Which gives me negative 81 over negative 16, which is a positive, right? So I should get a positive second derivative everywhere in the fourth quadrant, correct? So positive second derivative everywhere in the fourth quadrant, that is going to be answer choice C. So in this case, they didn't give us a point to plug in, but we were like thinking of what the points in that area would look like, and we could make a conclusion. They would not give this to you if it were a way that you could not tell for sure that it would be positive or negative. They would have to give you something. They could have put an X in there. They could have put an X right there on top, because you know the X is positive. It wouldn't have changed anything. What they could not have done is done like negative 81 plus X, because you wouldn't know how big the X was. That top could be positive or negative, so they won't do that there. For that. Okay, we are going to do 4, and then we'll skip over to the homework, because I accidentally put 4 and 5 are basically the same problem. I meant to put one of them on the homework and not here. So at how many points on the curve that's given here is the XY plane, in the XY plane, does the curve have a tangent line that is horizontal? All right, tangent line, horizontal. What's that mean? Slope of 0, and what do we use for the slope? Derivative. dy dx equals 0. So we want to know how many times the derivative equals 0. So we need to find the derivative of this. So we will take our derivative. We will get 2/3 x to what power? Negative 1/3 plus 2/3 y to the negative 1/3. And what does that need with it? dy dx. And that will equal 0. So let's move the 2/3 x and negative 1/3 over to the other side. get 2/3 x to the negative 1/3, and it will be negative over there on that left side, right side. And then I will divide by 2/3 y to the negative 1/3. What is going to happen with that negative 2/3 and the 2/3? They cancel, and we will get a negative 1. All right, make sure you keep the negative because one of them is negative, one of them is positive. So I got negative 1 x to the negative 1/3 y to the negative 1/3. Now that has negative exponents inside a fraction. I don't like it. So I'm going to move my negative exponents. So this is going to be negative y to the 1/3 over x to the 1/3. And if you want, you can write it like this. Negative cube root of y over cube root of x. Okay, that does not, that is our derivative. We need it to equal 0. Which piece of it's going to equal 0 for this to equal 0? The y. It is true, x cannot equal 0 in this case. So if we see like the x ends up equaling 0, we would need to throw that out. X cannot equal 0 in this case, but y is going to equal 0. So you might be inclined to say, oh, this happens one time. However, that's just one coordinate. When we're talking implicit, we need to know if this is even on the graph in the first place. So what should we do to, because and there could be like multiple x coordinates that go with this y coordinate, right? So what do we need to do to figure out if that's one point, or it could even like not be on the graph at all? We're going to plug it back into the original. So we are going to do x to the 2/3 plus 0 to the 2/3 equals 9. And I am going to, well, I'm going to have x to the 2/3 equals 9. There's several ways to deal with this. So, yeah, so you can write, one way you can deal with it is do like the cube root of x squared equals 9. So to solve that, you would need to do cube both sides. Oh, 9 cubed is going to start to get big. I don't want to deal with that, so I'm just going to write x squared equals 9 cubed. Here's y. 9's a perfect square, right? I need to square root both sides next. So I could think of it like this, or I can think of it as the square root of 9 to the 3rd. What is the square root of 9? 3 to the 3rd is going to give us 27. But, oh wait, I did mess up there. I forgot something. If I square root both sides, what have I got to do? Plus or minus. For that. So, since I've got the plus or minus, that is 2 separate points. I've got the point 27, 0, and negative 27, 0 are both on that graph. So that is 2 different points. Okay, we're not going to do 5 right now because 5 is like number 4. Very similar, just different denominator right there. Let's open up. Let's get the homework because there's one on the homework. I got to remember which one it is that is similar that we have not done a problem like, and we need to see. No, you should be at 3. It's just 3 is like that review problem we did at the beginning. It's just asking for the derivative. It's is it 4? Or is it 5? Let me look at my work on these. I hope I've got work on these. Okay, number 5. I've got it written here. Number 5 is the one I wanted to do. 4, we didn't do one exactly like that, but it says where the derivative does not exist. What are you going to do if you want to know where the derivative does not exist? It's undefined. Denominator equals 0. So take the derivative, denominator equals 0 for that. Yeah, 5 is the one that we need to see. 7 is like 5. So once we do 5, 7 is similar to 5. And get my work out here for this too, because might be a little shaky on this one. It's not that long. It's just I need to make sure I'm doing it right. You know, anytime you put plus n pi or 2n pi or something there, it starts to be a little scary.
Is n just a variable?
N is an integer in that case because it tells you that it's a non-negative integer. So we'll talk about it. Okay. All right. So which of the following describes the y coordinates of the points on the curve in the xy plane where the curve has a vertical tangent line? What are we looking at when we have vertical tangent line? All right, so the derivative is undefined, which means that the denominator equals 0. All right, so for this, we are, like the other problems, taking the derivative when you set the denominator equal to 0. Similar to 4, it's just we're going to run into some different things here. So the derivative of this is not all that difficult to take. What is the derivative of e to the x? E to the x. What is the derivative of sine? Cosine. But because that is a y, I need dy dx to go with it. Okay? So I'm going to divide both sines by cosine y. And so I have dy dx equals e to the x over cosine of y. Oh yeah, I remember this now too. This is terrible. Okay, I'm glad I opened my notebook because we get the wrong answer if I didn't. Okay, it's the work's not terrible. The explanation is crazy. All right, so definitely we are looking where cosine of y equals 0. That's what we're looking for. All right, and the question says which of the following describes the y coordinate. So we only have to talk about the y coordinate, so that's good. We need to look at the unit circle. We need to think about where cosine is y. Okay, so, or cosine y equals 0. So cosine y equals 0. So you know you're going to be like here, 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 or here. Cosine is which coordinate? X. So that is right here, pi over 2, down here at 3 pi over 2. No, it does not. So for this, the question only asks us about the y coordinates. So the x coordinate of the unit circle does not mean it has to be an x. We could use any variable right there. So it could be, sometimes we use thetas, sometimes we use x's. We can use a y. So it really doesn't change anything. Now, they did not limit us to the unit circle, right? So this could keep going. It could be 5 pi over 2. It could be 7 pi over 2. It could go over here. It could be negative pi over 2. It could be negative 3 pi over 2. Or so you would think. Because, so the first time I did this problem, because I have it marked out on my sheet, basically you got pi over 2, right, is your first, all of these start with pi over 2, right? And then cosine of y is going to be equal 0 at basically every increment of pi, right? So if you go up by pi, that's half the circle, that gets you to 3 pi over 2. And then if you go up by pi again, that gets you to 5 pi over 2. And then that would just keep on going. So I originally had this as my answer, where it's going to be pi over 2 plus n pi means, basically just means you can add pi an infinite number of times, or in this case, it says all integers. Integers can be positive or negative, so you could also subtract. So I had this as my answer because you could go up by pi or down by pi, and you would still get this as your answer. I did not do A because non-negative, there's nothing about the unit circle that says we can't have negative values for that. So I went with C, and then I checked my answer, and I was wrong. It is not C. Okay, the reason is because you also have to think about your original problem. Okay? E to the x equals sine of y. What do we know about e to the x? It is always positive, which means sine of y has to be positive. For these two things to be equal to each other, right? So if I plug in 3 pi over 2, I will get into the original, I'll get e to the 3 pi over 2, I don't know what that is, but I know it's positive because that's always positive, is going to equal sine of 3 pi over 2. And that will be e to the 3 pi over 2 equals sine of 3 pi over 2 is negative 1. Can that be true? No, so it's not on the curve. So can this actually be 3 pi over 2? It cannot, because it won't go back into the original. It can be pi over 2, because e to the pi over 2 is going to be sine of pi over 2, which means e to the pi over 2 . Oh, I'm sorry. Well, oh, okay. I'm sorry. Here's the problem. I should not have put that 3 pi over 2 right there because they're different variables. They're different variables. They're not both y's. This is an x, and this is an x. So I shouldn't have been plugging that pi over 2 in there because the y is pi over 2. So e to the x could equal 1. That's a possibility. E to the x, that's not 3 pi over 2. That's an x. E to the x cannot equal negative 1. So we really can't have 3 pi over 2 or 7 pi over 2 or negative pi over 2. So instead of pi over 2 is really like our only answer we have on the unit circle, so it needs to be D, where you add that 2n pi is basically like 2 pi times n. You can add 2 pi as many times as you want, or you could subtract 2 pi. So pi over 2 works, but 3 pi over 2 does not. Thinking to look back at that original is really difficult to do on that. 7 is very similar, so I would encourage you to look back at the original on that one as well. We do need to look at last night's homework, but we only have 10 minutes. And I do not think 10 minutes is going to be long enough for us to put those problems up on the board. So let's save last night's homework until tomorrow. We're going to do that at the beginning of class tomorrow. And you got 10 minutes to go ahead and start on this homework, which is the stapled paper there. So let's work on that, I think, instead.